In this lecture, we will talk about creation of ndarray in NumPy in Python. To create a new array, you can follow different paths. The most common path is the one through a list or sequence of lists as arguments to the array function. So after we have imported the NumPy as np, so we can write, for example, np.array. Then the arguments is a list of lists here. So C will be an array of the size of 2-dimensional with the shape of 2-3. The array function addition to lists can accept the tuples and the sequence of tuples. So we can input the parentheses inside after the np.array. Then inside is a 2-dimensional tuple. So the results of using tuple and lists as arguments to create array is the same. And the E is a 3-dimensional. So E here is a 2-dimensional array and with the shape 3-3. And the dtype NumPy arrays are designed to contain a wide variety of data types we call dtype. We have seen simple integer and float numeric values. In addition, you can use the data type for string as well. For example, here we add 2 string lists inside the NumPy array function, and if you show the dtype of this array, it will be the less than symbol and U1. And if we show the dtype.name, it will be string 32-bit. So by default, the array function can associate the most suitable type according to the values contained in the sequence of lists or tuples. Actually, you can explicitly define the dtype using the dtype option as argument of the function. So for example, if you want to define an array with complex values we have learned in algebra in high school, you can use the dtype option as follows. For example, the input actually is the integer list, 2 integer lists, but we can write the dtype argument as complex. So if you show the dtype, it will be dtype complex 128 bits. And the NumPy array provides a set of functions that generate ndarrays with initial content created with different values depending on the functions. The 0 function, for example, creates a full array of zeros with dimensions defined by the shape argument, while the ones function creates an array full of ones in a very similar way. So np.zeros 3 will create a 2-dimensional array 3 by 3, all values are 0. And similarly, np1s 2, 3, 4 will create a 3-dimensional array with the shape 2, 3, 4 for each axis. All values are 1. And np_arrange 0, 10 will create a sequence of values between 0 and 10. Actually, it's 0, 1, 2, 3, 4, 5, 6, 9, with the step of 1 for between each value. And np_arrange 410 will create a sequence start from 4 to 9. And we can also choose the gap between one value and the next one in the sequence. So NP arrange 0, 12, 3 will create 0, 3, 6, 9. Yeah. And NP arrange 0, 6, and the third argument is 0.6 will create a sequence with the gap of 0, 6. So it will create 0, 0.6, 1.2, and 1.8, and so on. And the reshape and arrange can be combined to generate two-dimensional arrays. For example, we can use np.arrange 0, 12 dot reshape 3, 4. Then we'll create and 3, 4 array, two-dimensional array with the values from 0 to 11. And the line space function will generate a sequence of numbers based on the number of elements in the third argument. For example, np line space 0, 10, 5 means we'll create an array with 5 values equally distanced. So these are 5 values, not the gap, 5 values equally distanced between 0 and 10. The np_random will generate a random float numbers in the interval 0 and 1. So np_random3 will generate one-dimensional array of 3 numbers, and each one is inside the 0, 1. And np_random33 will generate a two-dimensional array with the shape 3, 3, each value between 0 and 1. We will show all these statements in Anaconda Spider. Let's open the file called section 10, the NumPy library.py, and the link to the file will be added in the description of this video. So we move to section 2, creation of ndarray. So first we import NumPy as np. Then list an argument array function. We create an array C. They are two-dimensional with 2 lists. Then we will show how is C. See the list is the array two-dimensional. This is first dimension, and inside the first dimension has three value. The array function can accept the tuples as well. So here we use the tuple, not list, in the array function. Then we will show D. Actually, it's the same array as this one when we used list. And this is the another array with tuples. A tuple, and combine the tuple and the list. You can use the tuple here, the list here. It's no problem. The two-dimensional array with 3, 3. First dimension is 3 line, and the second dimension is 3 column. Means for each line has 3 value. Types of data we can show. This is a string array, and the dtype is U1. We show the dtype here. Dtype is U1, and the dtype's name string 32. You can also use the complex dtype complex. Although we input the integer value for the two-dimensional array with 2 lists, but we can explicitly choose the complex for the dtype. We'll see. So it converts to the complex number. So 1 plus 0j, 2 plus 0j, so on. and we can use some functions to easily create arrays, zeros. So np0 is 3 by 3, all the values are 0, and ones, np.ones function creates three-dimensional with a 2, 3, 4 for the shape. So this is the 2, and inside each value of the 2, each element of the 2, first is the second is 3 line, and then inside each element of the second dimension they have 4 elements. So this is a 3-dimensional array with the 2, 3, and 4. Then we can create sequence number using np.arrange. So from 0 to 9, and we can start from 4, the sequence number 4 to 9, and we use the gap 3 when we create sequence number 3, 0, 3, 6, 9. Just note not include 12. Then sequence number, we can also use the gap with a decimal number 06, 006, 1.2, and so on. And we can use reshape with the arrange. Then a 2-dimensional array here will be created. 2-dimensional array. First dimension is 3, second dimension is 4. Then use line space to generate how many numbers. So here the 5 values with equally distanced, but just note here the 10 included in the line space. So arrange function, the 10, if we arrange a 10 not included, but line space function include the end value and include the second value. You can use a random number generator for the np.random. So here is a 1-dimensional array with 3 elements inside 0 and 1, and for this we use 3 for 2-dimensional array, random number 3 2-dimensional array, and each value between 0 and 1.